These are the frequently asked questions for section 2.6a1, and it says in exercises 5 through 10, describe how the graph of the given function can be obtained by transforming the graph of the reciprocal function g of x equals 1 over x, then identify the horizontal and vertical asymptotes and use limits to describe the corresponding behavior and sketch the graph of the function. So we're going to start with number 7. F of x equals 2x minus 1 over x plus 3. And we talked a lot in class about how this would be so much easier to do if we could see our a, h, and k pattern, basically our a over x minus h plus k. To get there, what we have to do is divide. So we actually take the x plus 3 and divide that into 2x minus 1 to see what we get. So our x plus 3, we need to make sure that we match that first term. So we're going to need to multiply that by 2. And that will give us 2x plus 6. And when we do that and we see that we match up those two x's, we'll go ahead and write our 2, which was what we just multiplied by, to get that. And then we'll change the signs and we will add. And that gives us a remainder of negative 7 over x plus 3. So this function just became y equals negative 7 over x plus 3, and then we would have that plus 2 right here. And the first part of this said, what we want to do is describe how the graph can be obtained by transforming the graph of the reciprocal function, which is just g of x equals 1 over x. So this is our f of x function right here. And we want to say, what do we see here that tells us what's going to happen with this graph? And we'll start down here and just follow the order of operations. So we've got some addition taking place there, but that is our x minus h. So if it's x minus h, that means this was actually going to go negative 3 for h, which is 3 units to the left. So shift, let me change colors here, shift 3 units left. And then I move to my numerator and I notice there's a negative, so that's reflect over the x-axis. And then the 7 is a vertical stretch, factor of 7. And then we have the plus 2, which is a shift up 2. So those are the transformations that would get us where we need to go. And then the next piece was identify the horizontal and vertical asymptotes. Well, we have our h, which is our vertical asymptote. So vertical asymptote will be x equals negative 3. Horizontal asymptote is our k, so that will be y equals 2. And I would just go ahead and put those on. Since they're going to have us make a sketch of this later anyway. All right, so there's vertical and horizontal asymptotes. Use limits to describe the corresponding behavior. Well, we probably want to have a little sketch of the graph in order to see that. And it did say sketch, but really we want to know where this is going to go. So what we would do is we would go back to the parent function, which really just deals with that negative 7 up there. And we would think about our negative 7 over x, and then we will just follow those translations that we see up there, which would be shifting 3 to the left and 2 up. So like I had said before, you just want to put something easy in, make a little table in your mind, and think, okay, if I put a 1 into this, I'm going to get negative 7. So 1, negative 7 is right here. And if I put a 2 into that, I'm going to get negative 3.5. But all of those things need to be moved up. And as I mentioned in class, at college, a lot of the times what we would do is say to ourselves, okay, so really what's happening is we have moved our origin from here to here. So instead of starting at 0, 0 to do all of the placing for those coordinates, we would go ahead and start at the intersection of these two asymptotes that we have here, which is right at this spot. So remember, I put a 1 in and I had a negative 7. So from this, I'm going to count 1 over and 1, 2, 3, 4, 5, 6, 7 down. And then from that intersection of my two asymptotes, I know that if I go 2 over, it's 1, 2, 3 and a half. So this is a branch. And then I can go over to the other side and say, okay, well, normally it would be I'd try -1. And if I put a -1 into this, I would get 7. So I would need to go left 1 and 1, 2, 3, 4, 5, 6, 7 to get that piece. And then if I went -2, I would have 3 and a half. And there it is. So those would be some easy ways to get the branches, because they do want us to talk about those limits as we approach those asymptotes. And in this case, we have that vertical asymptote at -3. So we want to talk about the limit as x approaches -3 from the left of f of x, and the limit as x approaches -3 from the right of f of x. So from the negative direction would be, as we're coming in from the left, what is the graph doing? And as you draw this from left to right, you can see it's going up. So this will be infinity. And then as we come in from the right for the other branch, we see here that this is going to go down. So positive infinity and negative infinity is the behavior that we are going to see for that graph as that approaches the asymptote that we have, the vertical asymptote at x equals -3. Now, the next thing we would do is say, okay, well, how about the end behavior? I mean, now that we have all of this here, what's the end behavior doing? And the limit as x approaches -infinity of f of x, and the limit as x approaches positive infinity of f of x is what we want to describe. So in general, as we go to the left forever with this graph, our graph is approaching that asymptote, which is 2. And as we go to the right forever for our graph, we are also approaching that horizontal asymptote, which is 2. So that's what we would want to do with those limits. And again, you know, that sketching process, we could just go back to what we were doing before in the book, which was figuring out where are these 2 points and then just counting them into their new positions, which would be 3 to the left and 2 up. Either way, however you can get that and be effective at it is what you want to do. Now, I believe that takes care of everything I wanted us to do with that one, and you still need number 9, so I'm going to go ahead and clear the page here. All right, now we'll start with number 9, and we're going to go about this the same way. The first thing I don't like about number 9 is they're messing with us a little bit by not making this -2x plus 5 over x plus 4. We can certainly reorder that. That's just addition, and addition is commutative. So what we want to do is take x plus 4 and divide that into -2x plus 5, which of course requires that we multiply by -2. And that would give us -2x minus 8. We know that that's working, so I'm going to put my -2 up there. And then we go ahead and change the signs and add, and we get 13 for a remainder. And this is how we change this function into that y equals a over x minus h plus k pattern that we like. So what we have right now for this function, let's see if I can fit all this on here, is going to be f of x equals, and we just want to put this in the front position, so 13 over x plus 4 and then minus 2. And then we want to go ahead and describe those transformations. So we'll start down in the denominator, and we see that that's x plus 4 and that's x minus h. So that means it was a -4. So this would shift left 4 units. And then we go to the numerator and see, hey, they multiplied that by 13. So that is a vertical stretch factor of 13. And then we have a -2 in the back, so that is shift 2 units down. And that is describing those transformations. The next piece that they wanted was those horizontal and vertical asymptotes. So horizontal asymptote, vertical asymptote. We usually start with the vertical asymptote. That's looking at that denominator and saying what number can't that be. That's going to be x equals -4. and our horizontal asymptote is what hangs out back, so that's y equals -2. And that's always a good place to start your graphing, is by getting those on there. Basically, you're telling yourself where this graph is not going to go. So x equals -4, and y equals -2. All right, so with this one, if we want to talk about the limits, again, we want to get a graphic on this. We do know, because our A is positive, that this one is going to be basically in that first and third quadrant when we go ahead to graph it. But what we would want to do is think about this as the graph of y equals 13 over x, and then we would go ahead and translate that to figure out where that's going to go. And that's a big blob there, so. All right. So if we put a 1 in there, we are going to get 13. And our graph here, because we have moved this down for our new origin, if we go 1 to the right and 13 up, we're right about there. And if we were to put a 2 into this graph, we would get 6.5. So from my new center, I will go over 2, 1, 2, 3, 4, 5, 6.5. And I would be really tempted, because those 2 points are kind of far off over there, to just throw something like a 4 in there and check and see. So if we put a 4 into this, that's going to go 3 1/4 times. And we start to see the curvature of this branch as we do that. And yeah, we know it's going to be, that's where it should have shown up. Now, if you're looking at this and thinking, okay, can we be sure where this particular point is? Well, yes, that's a piece we're going to pick up in the future. Right now, we're just going to do the best we can with what we've got. Okay, so next piece would be, if we were to put a -1 in here, we know we'd get -13, so that would be 1 to the left from our new center, and 13 down somewhere over here. If we were to put a -2 in there, we'd have -6.5. 1, 2, 3, 4, 5, 6.5. And then, as we did before, let's put a -4 in there. If we put -4 in there, we're going to get the -3 1/4. So again, we get a good look at what that branch is going to do. And that's going to enable us to talk about those limits that they wanted. So limit. As x approaches, we have a vertical asymptote here of -4 from the left. F of x is going where? Well, as we come in from the left, our graph is going down forever, so -infinity. The limit, as x approaches -4 from the positive direction, which is from the right, well, this graph is going up forever. So that's going to be infinity. Now, we have to go ahead and do our end behavior. I'm going to have to fit that down here. The limit as x approaches -infinity of f of x means, as we're going to the left forever, what exactly is this graph doing? And it is approaching that horizontal asymptote, which is -2. And our limit as x approaches positive infinity of f of x equals, well, it's the same thing. This is scooping down as we're going to the right forever, and it is getting closer and closer to y equals -2. So that, I believe, was everything we had to do for those two. There's a lot of steps in graphing and knowing where everything is going to go, but once you get pretty good at it, it goes pretty quickly. So exercises 11 through 14 says evaluate the limit based on the graph of f shown. And this one is the limit of f of x as x approaches infinity. So as we go to the right forever, what is this graph doing? Well, as we go to the right forever with this graph, f of x is approaching this line. And this line is the line y equals 0. The x-axis always has y equals 0 as its formal equation for a line. And then you have asked about number 17. Number 17, they want the limit as x approaches -infinity of f of x. So as we go this way forever, what is this graph doing? And we can see there's a cutoff, and that asymptote is right there. This one you have to fiddle with a little bit because we need to know about the y's, and they're not going by ones. And I know that because I look down here and I see that they went from -5 to 15. So this is a -5 units. That makes this 5, 10, and 15. That makes this y equals 5, and that's what they're approaching there. So that would be the limit for that horizontal asymptote. 20 and 21, these two, they want some information. It says find the horizontal and vertical asymptotes of f of x and use limits to describe the corresponding behavior. So for number 20, if we want to talk about those horizontal and vertical asymptotes, we can't use the methods that we did before, and that's because we have these squared terms, and we'll be talking about this as we get further and further into the section. But we certainly could say, you know what we know? We know that x squared plus 1, when that equals 0, that's bad news, and that's going to be a vertical asymptote. But we go ahead and start solving this, and we realize this is going to be imaginary. And so we don't get any real vertical asymptotes for number 20. And then the next thing we do is look for horizontal asymptotes. And horizontal asymptotes is when we want to think, as x gets bigger and bigger, what is this approaching? Well, this would be 3 times infinity, and this would be 3 times infinity squared, and this would be infinity squared plus 1. Plus 1 is spitting in the ocean. So that 3 is what's going to make the difference. And so that's going to be the line y equals 3. So we have a horizontal asymptote at y equals 3. We don't have vertical asymptote. But what we want to do is continue on to say, okay, here's what we think is going to happen with this graph so that we can talk about its limits. So here's what I know. I have a cutoff at y equals 3. And I'd like to know, where is this going to go? So one of the things that I would do would be to figure out maybe some nice, easy point that we could get. And that nice, easy point would be, when is 3x squared going to equal 0? Because if there's a 0 in the numerator, then we're going to be graphing 0 something, and we'd like to know where that goes. So if I divide both sides by 3, I get x squared equals 0, and 0, 0 is a point on this graph. Now I already know I have to approach my asymptotes, so what I would want to do is just make a little table in my head real quick and put in maybe a -1 and a 1 and see what's happening. So I go back to the original and I just put a 1 in, and that will give me 3 times 1 over 1 squared plus 1, and that's going to be 3/2. And if I put a -1 in there, a -1 when it's squared is going to give me the exact same answer. So I'll be able to see the symmetry at -1, 1.5. And again, this is just a sketch so that we can get the information that we need about limits. And it's going to look like that. I know it has to approach that asymptote. So the limit as x approaches -infinity of f of x is, well, as we go to the left forever, this is approaching 3. And the limit as f of x as x approaches positive infinity is also 3. That's what that is approaching. And those limits are the limits that we need. We don't have any vertical asymptotes here, so we can't talk about the limits as it approaches those asymptotes. So a quick little sketch with just a couple of points and a little thinking, and that's what we're going to learn as we go through this section. Just a little bit of thinking can get us what we need. Same thing with 21, where we can't really divide this to get a good idea of what's going on, but we could certainly say, all right, we know those vertical asymptotes come from when that denominator is 0. So that's going to be x equals 0 and x equals 1. So this time we're going to get 2 vertical asymptotes at x equals 0 and x equals 1. Horizontal asymptotes. Well, if I put infinity in here, this is just infinity, and this would be infinity squared. So that's going to be 1 over infinity, and as I put bigger and bigger numbers in there, that's going to approach 0. So we would have our horizontal asymptote of y equals 0. And then we'd go ahead again and make a sketch so that we can talk about the limits. And let's just say I'm going to really overdo this here and make that my 1. So I have my vertical asymptotes and my horizontal asymptote right here. So now I need to figure out where this graph is going to go. And for right now, you could grab your graphing calculator. As we get further in this, we're going to say absolutely not. But what I would want to do without a graphing calculator is just pick some numbers to the left of our line x equals 0. So something like -1, -2, -3, and put those back into the original and see what we get. Well, if we put a -1 in, we're going to get a -1/2. If we put a -2 in, we're going to get a -1/2. And if we put a -3 in, we get a -5/12. So this is interesting. What's happening here is we've dipped a little bit below, but then we are coming back to those asymptotes. We have to. I mean, they're asymptotes. That's what happens. And you'll notice we did cross the horizontal asymptote, and remember that happens from time to time. And then I'd want some points for this little section that's in between these. And so I just picked some nice easy fractions like 1/4, 1/2, and 3/4, and put those back into the original to see what I would get. So with 1/4, it was -8. With 1/2, it was -8. And then for 3/4, -13 and a third. So it's doing something like this in that middle portion. Then off to the other side, I would need something beyond that asymptote of 1. So I went ahead and tried 2 and 3. And 2, putting a 2 back into the original. 2 times 2 is 4. 4 plus 1 is 5. And then we get 4 squared minus that 2. So that would give us 5/2, which is 2.5. So 2, 2.5. And then we have 3. And when you put 3 in there, you get 7, 6. So we see that that's the way those branches are going to go. So limits for those corresponding behavior, we would want to talk about what's happening, whether or not it's at the vertical asymptotes or it's going to be the overall behavior. So let's get the overall behavior done first. The limit as x approaches -infinity of f of x is, well, it is approaching our asymptote at 0. The limit of f of x as x approaches positive infinity, well, that is also going to be 0. But now we have a couple of vertical asymptotes here. So let me erase my table so you can still see everything that we need here. So the limit, and the first one is at 0, as x approaches 0 from the left of f of x is. It's going up forever. The limit of f of x as x approaches 0 from the positive direction, well, that's this piece. It's going down. Then we have the limit as x approaches 1 from the left. Well, as we approach 1 from the left, we're going down. And the limit as x approaches 1 from the right, as we come in, that's approaching our asymptote, which is going to take that up forever, which is going to be infinity. So lots of limits to talk about on that one. But that will do it.